the article, 1996 article by Mark Schervish that was in the American Statistician. I remember I liked this article when it first came out. It was pretty thought-provoking and kind of curious. And so I really am going against Knut's advice of avoiding religious wars because I just couldn't resist, and I wanted to just put up a background question that everyone should be asking themselves, in my view, which is once you settle on, say, a distribution or a model for the data, and you want to choose a measure of evidence that some effect is non-zero, let's say delta is a treatment difference, what makes more sense as a basis for deriving a measure of evidence, the proportion of repetitions of an experiment, if you could ever repeat it, for which some statistic that somebody made up or chose exceeds the observed test statistic from the original sample. And of course, that's the definition of p-value. And then there's the other major choice in terms of evidentiary statements, which is the more Bayesian posterior. So you might calculate the probability that the treatment effect is positive, and you can turn right around and calculate the probability that the treatment effect is negative, and use those two things to make a belief statement about the true treatment effect. So this discussion is all about choice number one, but we keep in mind that it's a very bizarre choice for evidentiary measures that many statisticians are very embarrassed about, that p-values became so popular. So in this paper by Schervish, the more directly related background is that we all know that p-values were derived to provide evidence against a hypothesis. And if you want to, as has just been discussed, the previous two discussants, want to give some sort of evidence supporting the hypothesis, p-values were never intended to do that. And Fisher, when asked what is the action you take when p is large, he says get more data. It's the only conclusion, the only action. So any evidence that you get in favor of a hypothesis H is going to be weak and indirect. So the question is, that was the older. So the question is, if p-values provide weak and indirect evidence in favor of a hypothesis, is that evidence itself even valid as an indirect weak measure? In other words, is it coherent evidence? So Schervish shows that it is not even good in that very weak sense. So whatever can go wrong with p-values tends to go wrong. And so the way that he derives this is that he writes down what we're not as used to seeing as applied statisticians, which is interval null hypotheses. And he just shows quite simply that as the interval shrinks, it can go to a point null hypothesis like we often have, or as one side of the interval goes to infinity or minus infinity, you get a one-sided hypothesis test. And he considers the very rigid case of a normal distribution with a known standard deviation of 1. And then in his section 2, he shows that as hypotheses, the point and one-sided hypotheses are limits of interval hypotheses, and so are the p-values limits. So the corresponding p-values are limits of p-values you get from interval hypotheses. So that all holds together and makes sense. So in section 3, he talks about one hypothesis that implies another. So a hypothesis H that implies if H is true, H prime has to be true. So if you skip down to the second bullet from the bottom, an example of that is if the hypothesis is that the population mean is between plus or minus 0.5, if you know it's between plus or minus 0.5, then you automatically know it's between minus 0.82 and plus 0.52. So H implies H prime. So H prime, or minus 0.82 to 0.52, is a weaker statement, a more easily satisfied statement. So a test of H and a test of H prime are coherent if the rejection of H prime implies the rejection of H. And so if you had a measure of indirect evidence that could be called a measure of support for a hypothesis, that measure would be coherent if whenever H implies H prime, the measure of support for H prime is greater than or equal to the measure of support for H. So to get concrete about it, if you take the interval hypothesis that the population mean is within plus or minus 0.5, and you calculated a p-value of that, if you had a single piece of data, which is 2.18 from a normal distribution with known variance, the p-value is 0.0502. But for the second hypothesis, which is an easier to satisfy hypothesis because the interval is bigger and it includes the first interval, the p-value is 0.0498. So it's saying that the support for the second interval, the indirect evidence for the second interval being holding the true mean, the support for that is weaker than the support for a more stringent hypothesis for a smaller subinterval. So that's an example of incoherence as an indirect measure of evidence in favor of a hypothesis. The p-value doesn't even satisfy that requirement. So this is all consistent with what the other papers said, and this is more relevant, I guess, to the Cohen paper. But the p-values don't really work in the way a lot of people think they work, even in the weakest possible sense of giving the correct rank ordering for support in favor. So that's just another nail in the coffin, in my view, for p-values, and it would again say that you might use them for evidence against something, but you never should use them as evidence in favor of something. So that's